Cool. Awesome. Hey guys, I just started recording, so quick disclaimer: if you guys don't want to be recorded, um, just turn your camera off, or you can watch the recording at a later time. But cool. I think we'll get started. So, hey guys, how's everyone doing? Thank you guys for coming out. So my name is Jaden. Part of one of two of IEEE's technical chairs, and the other one is Angela. She's also in here. And yeah, today we're going to be doing a systems design workshop. So this is kind of a new thing in terms of like workshops that we've done. Just a quick poll, if you guys could go in the chat, how many people are familiar with what system design is? Like, what is it? Does anyone have any recollection of, or experience, rather, whether it be like interview or class experience? And if it's totally, I mean, if you're totally new to it, it's totally fine too. But linear control systems. Okay. Yeah. Right. I think so. Yeah. Right. So I think this is going to be. I think it's has similarities, right? But I think what we're going to be doing today is we're really going to be pivoting towards system design questions that are much pivoted towards like software engineering and software jobs. So it will be designing complex systems, whether it be, we'll design some good ones like URL shorteners. If we get time, we'll do a Twitter design. So a quick thing, a lot of the design that we're going to do are the most prevalent system designs that are asked in companies, such as like Microsoft, Twitter, Google. All of these questions are curated from a list of companies that actually have asked these, right? So my friend got this like on his Microsoft, my other friend got it on Twitter, Facebook, whatever. So these are very much important. I know interview season is coming along. So yeah, let's go ahead and get started. Okay, let me minimize that. Recording. Cool. And then if anything is like any technical stuff, just ping the chat. I'll make sure to see it. Are there any questions before we get started? Does anyone have any questions about how the workshop's going to work? First, let me give like a brief description. So what's going to happen is we're going to go through the string of questions together, these like high-level system design questions. And I'm going to be using method draw to kind of illustrate the system that we'll be designing. So I'll be kind of whiteboarding that, stuff like that too. So let me get the chat. You guys are able to see that. Okay, cool. Are there any questions before we start? All right, cool. Let's go get started then. But yeah, welcome to system design. So today, what we're going to be focusing on is we're going to be doing a lot of sort of software design systems, and it's very, to be honest with you, I am a little bit newer to system design as I am to other topics. And at first I was like, okay, well, I mean, it's very trivial, right? Like, if they ask me to design a URL shortener, right, like that's very easy, right? I mean, if if you've had, most people have a rough idea of maybe how they would do that. Even if you don't, it's fine. But I was like, okay, I mean, it's not that bad. And if you really think of it as a scope for system design, for software at least, it's way more involved, to say the least. There's a lot of things you need to take into account. A lot of things like scalability. How are you going to market this? More things that expand basically just the brunt of the technical system, right? How are you going to ensure that there is no downtime? How are you going to ensure that it works on all platforms, on all users? How are you going to virtualize it? How are you going to... So we're going to go over all of those nitty-gritty things as we kind of begin. Also, I think this workshop will end a bit earlier, probably around 7, so everyone can, I want to host a workshop that has quality stuff, not just drag it out. So yeah, let's get started. Cool. So, what is systems design? Um, so this is kind of the, you can look through the definition, but does anyone have really a very concise definition of what you guys interpret system design as um, at the moment? Like, what do you see? Because it system design really means different things to different people, depending on what, first off, what occupation you're in, what are you using it for, and kind of what setting. So first off, what is system design, right? So to me, system design, for me in mine is more of kind of designing these systems, these architectures and interfaces. This it's high level, right? So very maybe rarely you'll be asked to kind of do the brunt of like these kinds of algorithms and data structures. But at a very high level, what system design is it's kind of making these elegant applications. So if anyone's familiar in let's say what like a full stack web development, right? It's really not just the actual full stack in general of making the server, the database, the front layer and stuff like that, but it's actually the entire encapsulation of how are you going to make this deployable, how are you going to make this scalable for multiple users. So there's a lot that comes into play other than just, I'm going to make a API here and I'm going to make a front end here, right? So it's very in depth and there's a lot of complexities, and system design is all about trade-offs. So, you know, there's trade-offs between, hey, am I going to scale this way? Am I going to cater towards this party? Am I going to prioritize the tech or kind of the fast pace of the system? There's a lot of pros and cons um, of each kind of system. So anyway, the formal definition, right, is like I said, it's kind of every application around you is kind of wrapped in sort of complex systems. So let's like the Google slides that we're on, right? There's a whole system, a lot of like many moving parts that are going to make these into play, right? We need compatibility for this Google slides. We need scalability, how this ensures that, as more users are frequented on this page, we can ensure that our use cases scale. And that's a huge part. There's a technology in general. There's a lot of different moving parts. So this is kind of what we're going to be doing. We're going to be breaking down a very simple task, and we're going to really be going in depth. And what I hope to give you guys before we leave here is not so much the content of the system that we design, but the problem solving mindset that we can approach to designing any system, right? Like, when you come out of here, you're going to learn how to design a URL shortener, right? But the main thing that I want to try to hit home is how can you take these techniques of system design to any interview, any kind of application that you want, right? Not even for interviews. If you want to make a system, if you're really interested in infrastructure and architecture, how are we going to kind of get there? So yeah, hopefully I can drive home like that problem solving and those techniques, right? Rather than just this is how we're gonna do Twitter, right? Like I'm pretty sure when you actually get that question, you're probably gonna forget stuff like that. But are there any questions about like kind of what system design is, what career paths there are, and what it can be used for? Um, and also, if you guys have any questions, you can unmute if you don't want to use the chat. So, but yeah, and you can also think of system design as kind of connecting these dots and pieces of technologies together to make this like beautiful application, right? So you're sort of connecting these bits and pieces, these separate technologies and APIs, and you're all bundling them together, and you're making a beautiful system. And that's how you know that's how you're gonna kind of go about it, right? So cool. So if there's no questions, so why should I even care about system design? Like what is system design? Like what is this, right? So, it's essential really for any kind of new grad position, especially for going to senior software engineering. I mean, for new grad interviews, especially if you're looking for a software engineering job, not even software, but any kind of probably any real system, I'd assume that if you're more hardware based, you would probably do more of like what Jacinth was saying with linear control systems and kind of more in-depth hardware-based systems, right? But in general, right, system design is very essential. A lot of them incorporate system design. I know what I did before this workshop was just ask a bunch of people working at these companies, like, what system design questions did you get? And what was one thing that you can learn? And the thing is, a lot of people leak code, right? You know, me personally, I do a lot of data structure and algorithm stuff, right? But what we miss is how to, you know, design these systems, how we sort of underestimate them, right? Because it's like, okay, well, you know, I can think of something on the fly. I can think of, you know, someone asked me how to design a URL shortener. I can easily do that, right? You know, what I at least came in, but it turns out it's way more complex than it actually is, right? Yeah, and then it seems. Sorry. So so all these internships. So I've asked people from Tesla, Apple, Viasat, and all these people. They've had some sort of system design question, and it's also good to have a high level understanding of the environment systems you're coding in, right? So you know, having that high level understanding of, you know, this is what I'm working around. These are all the parts that are connecting my part. Yeah, it's good to kind of break down these sort of applications, right? Like to their very core and see how they work, right? So let me so yeah, so like, and obviously it's like it's pretty interesting. Right? Like I want to see how Twitter is gonna work. I want to see how this works. I would love to just break stuff down, right? So okay, so let's just reset everything and we'll just start at well, first off, does anyone have any questions about kind of use cases? Why is this even important? Like, why should we even learn systems design? Does anyone have any questions? Okay, cool. So, right. So let's start very small. Let's just bring it back to the very beginning. Let's suppose that you write some code, some, you know, some basic algorithm. I'm going to be using method draw. It's just kind of a sketch. I want to be doing the systems interactively. Also, my drawings might not be the best, but hopefully you can bear with me. Okay, so let's say that we have some code, right? We have this system. We'll just say code, and right. So we have this algorithm, right? We have this box. Um, oh, I'm not sharing. Oh, am I really not? Oh, I'm so sorry. Thank you guys. I totally thought I was. Sorry about that. Jeez, my bad. All right, sorry guys. I am sharing now. Thank you for that. Do you guys see everything? Cool. Thanks, man. Okay, so like I said, so let's start very small, right? Let's suppose that we're writing some code, some basic algorithm, some basic input and output, right? So I'm actually using method draw. You guys can see this, right? Um, so I have this algorithm, and it's just this basic code, right? It's function, it's an input, output, whatever you want, right? And now let's suppose that your code is so useful. Like you have this pathfinding algorithm you came up with. You have some sort of, I don't know. So you have some facial recognition, this new, you know, top of the line new facial recognition algorithm. And, you know, so it's very useful, right? Like a lot of people like it. They're like, wow, you know, I've never really seen this before. I want to purchase this, right? Well, you know, that's all good and all, and you have the algorithm, you have the method of doing things, but there's really no, you know, sort of way, like how are we going to go from your code, your function, your input and output to something, let's say that a phone would use. So I'll have this, we'll label P, we'll let P be a client or a phone that is here. So how do we ensure that we get the algorithm and we get the code in a very scalable and safe manner to the client, right? Like how do we go about this whole process of getting your code here, right? Because it's not that easy, right? Like there's so much more that we have to build upon. Right. So first off, you guys can see the slides, but are there any questions or suggestions on how I would sort of get started? So this is basically just a, this is first just like the basics, like the, of what system design is, and then we'll actually go into the problem. I just want to really strap down the idea of what we're doing. So, right. So we have this algorithm. This everything makes sense right now. Like we have this code, and next, right, we need something to run this on, right? Because we just have this code, we have this function, right? You know, if we do a Python script, if we do anything else, it'll just run and then it executes. What we need is we need to define sort of a bigger server, right? Such that this component is kind of easily ran, right? Like it's easily, oops, sorry about that. It's easily ran in a very elegant way. So does anyone know kind of what a server would entail, how to go about this? And does anyone have any idea of like what a certain server is in relation to the code that we just made? Right. Well, so first up, we need to think, right? So this is kind of the basics of what we're trying to sort of do. And let me just make one here. Okay. So what we can do is we can kind of migrate this code and we can kind of deploy it on something called a server. So we have this code, right? And the only way to get this algorithm working at I'd say consistent, so there's a concept that we should know, and this is called something being asynchronous, right? If we have this code and we just keep running it on a Python file or whatever, then it's gonna, it's gonna kind of execute and then it's gonna quit. We need some sort of server that has sort of a proxy to kind of get the algorithm to and from wherever we want it, right? We need a place to kind of nest this so that whenever somebody accesses such server, we're able to sort of kind of grab it whenever we want, right? It's up, it's always up, it's always running. The runtime is always there, right? So we need code, and we're gonna have another text here, and we would put a server. And what this server is, it's basically saying, okay, well, every time that I am accessing, right, this server, then this code will kind of run. This code will run. This code will do whatever it wants, right? It'll become available to you. It will run on its own. Really anything, right? So we have this sort of base of, okay, well, we would need to put a code in a server. Now, let's set up this thing called an API. So what is sort of an API? Like, what is it doing? So we have this client, we have this server, we have this code. And API is a term that gets thrown around a lot. A lot of people use it for many different things. But how I like to think of it is it's literally just a bridge to get one technology talking to another technology. That's all it is, right? We have one technology here, which is our phone or our client, and we have another technology. It's our server that hosts this algorithm on. And all we really need to do is construct, an API. And what this, let's label it green or something. Sorry for my irresponsible color choices, but right. So what is this doing? So if I have this API, stands for an application programming interface, what we get is this server without this API, right? Without this API, we just have a box. And how are we able to communicate when we want to open and close the box? There's no real way. I mean, there is workarounds, but a very nice and elegant way of how to sort of get this algorithm to this client is by using an API. And what this API is doing is it's sort of getting two things, right? Does anyone know what these two, I'm going to draw, let's say, that I have this guy and I have this guy. Does anyone have an idea of what these two lines would represent in our input and output? Right. It basically is. Yes, exactly. It is. It's basically the input and output of what we're doing, right? However, there is a formal definition, but what you said is basically correct, right? We have this phone, and what is this phone gonna do? And you've probably heard this many times, right? Okay, white would not be the good color here. Well, this phone, what it's gonna be doing is it's going to be sending a request. And why is this not a request? What's going to happen is this phone is, we can think of this phone as a client. And what this client is going to send is a request. And what this request is doing is it's requesting information. We're saying, hey, okay, well, I have this phone. I have, I want to get your algorithm. I really want to get whatever it be. I want to get your machine learning algorithm. I want to get your function. What this client is going to do is it's going to request data to the API. So it's saying, hey, API, I want to get, I'm going to give you my face and I want you to put it, I'm going to request, my request is, okay, I'm going to give you my face and then the algorithm is going to happen and you're going to sort of give back a response that is, whatever you want, like a dog filter, right? So if we do this like in Google Maps, right, I'm going to request my location. I'm going to request what I want to do, and what I want to get back is sort of the response, right? I want to get back, let's say I want the optimal location from point A to B. So, this guy is going to go here. It's going to go in the API. The API is going to say, okay, this is what you want. It's going to go into the server, into the code. And now it's going to kind of bring back a response, right? So this is called a GET request, right? You're getting information.
Water bottle.
You probably heard. You're getting information from the server to whatever, right? So, yeah. So yeah. So are there any questions about this kind of simple exchange of information, right? So you guys have probably heard of different kind of requests. These are called like REST APIs. What these requests do is, this is a GET request, the simple one. If you get information, you're getting information from the server. Pretty soon we'll go over another request called POST request, which I'm pretty sure you guys have been familiar with. And what that is you're posting, right? You're sending data to a certain database, right? We don't have a database right now, but this is kind of the structure of how things kind of connect and work, right? Are there any questions around like this kind of exchange, this kind of like request exchange? Like the preliminaries? Cool. So I think everybody's on the same page here. So now, right, now we can add some core functionalities to this. Say we have this algorithm, right? We have the basic exchange, but there's really no sort of other real functionality. Let's say that we have a user, and in order for the user to use our algorithm, he needs to log in. But I mean, unless you use OAuth or something, is there any real thing that we can remember? This server, all it has is this algorithm, right? We don't have anything. Is there sort of anything that we can build that we can attach our very simple system to, such that we have an ability to store information that we can use dynamically, right? Does anyone have any ideas of what we can kind of use here? We can kind of extend. So, right. So this is another system. part of our system. And what we can do is, in order to kind of gather this, a base for a lot of these systems, is we can actually establish something small, be really whatever, but we would kind of make sort of transparent. We can make any color, let's say orange. But we can make a database, right? This is going to be our DB, our database. And I'm pretty sure, as if anyone's had experience with creating these applications, they're familiar. Like, okay, well, what a database is basically it's just a way to store data dynamically. And the data is coming from the server. And the data that, there's two things that the database can do, right? It can either accept data from the server. Let's say that somebody here from the client is posting their username, right? It goes through here, and this is their first time they're registering, right? Now it goes to the database. The database is able to correctly store information and whatnot, right? Like we're good on that. So it can also, not only store information, but it can also get information, right? Let's say that we're having a get request and we're trying to get the user's credentials to be logged in. Well, we would also need a database. We would just get, and what we would do is we would say, okay, well, I'm requesting authorization. So what it's going to do is from the client, it's going to go to the API, and the API is going to say, okay, what are you doing? It's going to say, I need authorization. So it's going to say, okay, before it goes and gives you the code, the algorithm, it's going to go to the database and do some error checking if it's correct or not. And then it's going to return back to the server and eventually get you a response. Your response can either be, hey, your credentials are invalid, you might have entered something wrong, or you're authenticated, and then it will just, put you into the website, right? So this is sort of the base of what and also if this is like, if there's some people where it's like, okay, this is too easy, don't worry, it's gonna get way more complex than this. I just want to really give you guys a basic understanding so I can level the playing field, so everyone has that sort of general base of knowledge, if that makes sense. So we have this simple system. We have a database, we have a server with our algorithm, we have an API that kind of communicates, okay, I want to request this, I want to give this as a response. And what else can we do? Well, let's say that we have certain downtime on our application, and we want to ensure that our application is proctored by the right party, right? So we can add support for this. I'm pretty sure you guys have heard of Amazon Web Services, very prevalent. You can add AWS. There are AWS packages and managers that sort of ensure, and they give you automatic cloud managers to manage this. So it's like, what if some guy does a DNS overload and just totally destroys your API with a million requests, not a million, but like just saying, infinite number of requests. You can have precautions. First off, you can put in your server, but you can also have error checking and security in AWS. So we can just add AWS. And like I said, it's very broad, right? There's a lot of things that AWS can kind of sort of do, right? There's so many different resources it can. But anyway, right. So you'll see at a lot of applications using AWS. Maybe AWS is actually sort of in here. It's actually pasted in your server where you can use things like TextRack to extract, cool machine learning stuff. It really depends, but you can also use it for functionality and stuff like that. So these are the basics, right? These are kind of what a very basic system would undergo. Obviously, we can talk about other things that should be supported, but are there any questions about this like baseline of system? Does anyone have any comments or anything? Is anyone unfamiliar with what one of these things do? Cool. Okay, cool. So this is our basic system, and I think everybody's like, okay, well, yeah, that's it. Now let's get really into kind of what we are kind of in for the system design and the drawbacks. Let's talk about scalability. So if you guys haven't heard the term, you'll very much in the industry and in tech companies and stuff, you'll get thrown around. Okay, what about scalability? What else? Scalability this, scalability that. It's a very hot word. And there's mainly two kinds of scaling. There's vertical scaling and horizontal scaling, right? So if we have this system, right? Let's suppose that we have now, a lot of people really like your algorithm in the terms of maybe hundreds of thousands to millions. People really like your pathfinding algorithm or something. So what we can do, so let's say, suppose that there is, let's say that there is multiple clients, right? So we have like an n number of clients and they're all kind of hitting this API. You're like, oh, okay, I really love this app. I love what I'm doing. Right? We have a multitude of clients now. And how do we ensure that as the number of users increase, the number of support and functionality that we can get? How do we ensure that all the users are guaranteed, the correctness and the of your algorithm, because they're paying for it, right? Like, whether you buy ads or by subscription or by straight up like paying for your algorithm. But how do we ensure this? We can employ things called scalability, and there's vertical and horizontal scaling. So vertical scaling is, we take, let's say that we have this, and all it really is we just build a bigger server. We just make the server bigger, right? We yeah, we basically just say, okay, well, I'm going to scale, I'm going to upgrade, I'm going to get more system requirements, more computation power, and I'm going to make sure that this server is up and running, right? So let's say that we employ vertical scaling. We're going to have a big server, right? So server, and we'll just call it out, whatever, right? So that is just making sure that the server that you have is way bigger in processing power. There's a lot of systems that can do that. A lot of services, AWS, again, they're very good for that. The scaling systems, servers, there's a lot of cloud infrastructure stuff in the market right now, right? So that's the one thing. The second thing is not only just your server, but horizontal scaling. And what is horizontal scaling? Well, horizontal scaling is instead of building one huge server, horizontal scaling is instead we sort of employ multiple smaller servers and scale horizontally, right? We have more servers that are smaller, right? And before we get into it, you guys can look at the slides, but does anyone have any, let's think of vertical scaling, right? Is there any pros that you guys would think of vertical scaling? Let's say that you have this application, you have this server. Do you guys think that, you can type in the chat, what are some pros of being able to kind of say, okay, I want to scale my server vertically. I want to scale vertically. Are there any benefits of that? High performance computing, no complexity managing mobile. Right. So both of them are right, basically. So the first one, let's talk about high performance computing, right? We have this entry point that is a singular node, right? Such that you can optimize this however you want. We have this single entry point, right? Like we have this, it's centralized. The other thing, right, is no complexity in managing multiple servers. If we manage this guy, this is it, we're done, right? Like we need to make sure this is up and running. We don't need to worry about, hint, spoiler, load balancing, which we'll get into later. But exactly, so, if we go and we say, okay, well, let's look at vertical scaling, right? Right, and another thing is, if we think about the data that is getting transmitted, right? Let's suppose that we have these clients, and each client, instead of this server, is going There's some sort of load balancer that we'll get into, but it's now getting equally distributed into multiple servers, stuff like that, right? Instead of going to this server, we're mimicking that, and we're actually just distributing the weight into multiple servers. So what are the tips of the vertical one? So the vertical one is, if we just had like the previous example below, let's suppose that we just scaled this guy, right? Then it's really good because the data stays consistent. We have a single point of entry where, let's say that we have these servers. I mean, we need to ensure for all of these servers that the data stays consistent, or else we're going to have corruption. And nobody wants data corruption in any application. It just renders the whole thing incomplete. Right. So single point of entry, really good. And data consistency, we have high performance, right? What are some cons that you guys think that a server might exhibit? Something that, some kind of things that would be bad of having a vertical scaling server. Let's say that we only have one server and it's very high performance. What are some bad things that we can? Fault tolerance, right? So fault tolerance is very essential, right? Because if you have a single, one of the good things about a vertical scaling server is single point of entry. One of the bad things about a vertical scaling server is a single point of entry, right? You have this one node, this one single point of entry, and at any point, really, is it acceptable to shut down? Let's say that you have downtime. B, some sort of breach, whether it be an attack or some sort of system breach or something, whether it be, um, intentional or non-intentional. And, that can be a real problem, right? Like, if you have a server and it's just huge, and then this server goes down, well, you're basically screwed. Like, that's it. Your app's done. Whereas, let's say that we have this server goes south and gets off. Well, what we can do is we have a load balancer, we'll discuss later. We can also just be, okay, well, we can just do that. And we can just adjust, and which really helps. So it's very easily, so a con for having a single server would be it's very hard to scale, right? Like if you're scaling this server, lastly, it's very evident that, this day and age, like we have great technology, but there are hardware limitations, right? So that would be another one. Like there's a limit for how good it can be, right? Like we can have this much computation power. It can only go this far. So in terms of scalability, strictly vertically scaling would not be the best move, right? Because you kind of have a single node and it's really easy to get stumped, and you can only buy so much computation power on that one server. So cool, yeah, so that was a big thing. Vertical scaling is crazy important. Let's talk about horizontal scaling. What do you guys think would be the most important thing, the most important pro of being able to scale your server horizontally with all of these nodes? So, right, so there's a lot of pros for horizontal scaling, right? One is that it's very resilient, which means that there is no single point of failure, as we said, right? Like we go here, this will be okay. Well, we found some node that's down. We can just extend this server and we can do that. Right? There's a lot of opportunity when some things go south, where horizontal scaling is very good, right? It's very scalable. If you're having a lot of users, it's very scalable. So scales well as load users increase. A con of this, right? Something bad would, well, not really a con, but you need to require some sort of load balancing, and we'll go over that later. But basically what I'm trying to say is that how do we ensure that given n clients, all of these sort of clients here, how do we ensure that all of these clients go to a server in an equal distribution of weight? So these will be all equally distributed in weight, right? Like how do we balance the load of traffic in our server? That's basically what balancing is. And it's very prone to data inconsistency, right? Because this is a con, because if we have this one server, we have this central hub of data where we can sort of query and store information as we want. However, if we have multiple servers, we need to ensure that it's replicated, which means that, okay, well, if this guy posts a 1, the data needs to be replicated across all of the servers, right? So if we have a 1 here, we're going to have a 1 here. We're going to have a 1 here. That takes time. That takes, energy. It takes a lot, right? And that's a con, right? Because, all of that runtime, all that computation power can easily be avoided if we have a vertically scaling server. So that's kind of what scaling is. You're going to get thrown about that word a lot. Yeah. So are there any questions about like the basics of horizontal versus vertical scaling? Anyone have any questions? Cool. Okay, so we did that, and okay, so before we move on, I'm just curious. Does anyone know like what the best solution is? Like, what do you guys think if you were like a senior engineer, a software engineer, electrical engineer, and you're asked to design such a system? What would you choose and why? Like, what would be the most optimal choice that you can make, whether it be horizontal scaling or vertical scaling? I'm curious, like, to see. Make them both scale, right? So the answer is, yep, exactly. We would just do both, right? We would do exactly. We both scale both of them, right? And in a way such that we have vertical scaling, we have horizontal scaling. What if what we did was the hybrid solution that literally 99% of companies and crazy enterprises do is they do both. So let's say that we have horizontal scaling here, right? But we scale each horizontal scaling at a vertical level. So we have this huge box, and whenever we need a new box, we'll just sort of make another huge box. And we're kind of having the best of both worlds, right? Because we have these different nodes. However, each of them are scaled at a very high level, right? Does that make sense? So it's very optimal to just do both, right? Like there is no best. It's always good to know one of them. Like I personally got asked like what is vertical versus horizontal scaling. It's very important. But yeah, so definitely a hybrid solution of both of them are very good. So are there any questions about scaling, about like what the importance of it, what it is, anything? The overall scaling is limited by computing power only. Well, let's see. There are a lot of computing power is a factor in the limitations of scaling. However, there are other things, right? Like let's say that you are this company and you're very private and you need your data, SSL and successfully encrypted, right? You're not going to choose any kind of storing powerhouse. You want to make sure that the servers, when you scale, are successfully safe. They're safeguarded. So security is a very big factor. So in physically scaling a server, right? Like if you're just talking about vertical scaling, then yeah, I mean, you can only have so much computation power. I mean, if we go on like AWS's main website right now, you get to see the different cloud levels, right? Like you can have this many gigabytes, right? And yeah, and you can, you can upgrade the most premium plan, right? Like the little plan, like intuitively is going to get you this bigger, 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 bigger. And then you have enterprise scaling, which they actually don't put on the website. Like you're not going to see that plan, just because I think directly they need like meetings and to go over how we're going to scale this, our company system, right? Like if a huge company went to Amazon, they're not going to just like go online and be like, yeah, I'm going to take this plan. It's much more involved. So yeah, that's basically what horizontal and vertical scaling is. It's a good question. In terms of physical ramifications, it would just be limited by computing power. Yeah. Yeah. So we'll send out sort of something on the probably the Facebook page, an email, even anything like Messenger or something. I not too sure, but yeah, it'll definitely be recorded. We'll have it, so we'll make sure to send it back to you. So yeah, no worries at all. You guys you can always do this at a later time. So yep, upload it to YouTube. Nice, cool. So yeah, nice. So any other questions? All right, cool. So if there's no more questions, we'll go on. Let's see. Okay, so before we start our main like system that we're gonna be doing, some basic little terminology, right? Let's say we have some terminology. So like I was saying, I was kind of beating around the bush, but what is load balancing, right? So let's say that people love your product, like you have this algorithm, people love it, and you have more money to afford new servers, right? Like you want to scale, you want to vertically scale, horizontally scale, you want to do both. And let's say that you have n servers. You want to balance the load such that all these servers have an equal load of traffic coming in and out of them, right? So all you're basically saying is, okay, well, I have all of these different servers and I have, let's say I have like way more clients. I have this guy, I have a tablet, whatever, right? I have all of these guys. And we need to sort of have this function or this deterministic approach in order to balance these servers equally. And it's way more complicated than I'm playing it out as. I just, during this workshop, it's more of an introduction to what system design is. If someone asks you what load balancing is, they're not going to tell you, hey, what is it called? For more in-depth explanation, you can look up consistent hashing and see how load balancing plays out. Right? But like, I'm not going to give you a crazy hash method and probability analysis of like what server to use. But if someone asks you, like in an interview, what is load balancing? Like, or you've like heard about this, right? It's basically, you want to balance the load of all of these requests such that all these servers have an equal load of traffic coming in and out of them, right? So it's very elegant. It's like, okay, how do we optimize this? And load balancing isn't just initializing the load to be balanced. Like, what if this gets out of the way, right? Then okay, we need to adjust. Some goes here, some points go here, some nodes go here. There's a lot really to it. Okay. Are there any questions about load balancing? I know it's a little interesting topic. There's actually whole like books written on it, like on optimizations and stuff like that. So, oops, pretty cool stuff though. Cool. Let's see how load balancing plays out. Okay. Nice. So we did our demo. We were doing it. Okay. So some terminology before we start. And did that. And okay. So our first system is going to be designing a URL shortener. This is the most notoriously asked question for new grad in system design, I believe. It's probably the most. I know my friend got this for Microsoft, and then my other one got it for like one of his I don't know what company, but it's very notorious, and it's a very deceivingly simple design that a lot of people overlook and end up actually not doing too well. But anyway, you guys have all had it. You guys have done tiny URL bit.ly, whatever, right? Like anything that you guys have done where, TLDR is we make a, um, okay, we make a long URL, right? We have this long URL and like, let's say that like we have this URL w.hello, and it's gonna have like, we can have this like huge string of characters, right? We have this, and what we want to do is you want to condense it into maybe like a 7-letter like hash, like that. Right? We just want to condense the URL. We want to literally shorten the URL. So, okay. So first off, when we're asked this, like let's say that we're in an interview and then it's just saying, hey, can you design me a scalable URL shortener? Okay. Well, first, how do we get started? First off, we don't underestimate the problem. It's never this, that's it. Okay. We can talk about how to implement the shortener, but it's a different question of just implementing a URL shortener for a singular device and implementing a URL shortener to scale, right? Those are two completely different things. You can scale, like you can make a URL shortener and have it work on your machine, like the meme, like it works on my machine. But how are we gonna make this to scale, right? Let's there's always something to ask. There's literally always something, right? Like these system design interviews these systems are gonna be used by like, assume that always ask the interviewer, but like millions of users will be using this system, right? And like, if you think about it, like if we had, sorry, it's very clunky, but if we had this like one API here, and we like think of, let's say that we get 3 million requests a day, I don't think that this API is going to run 100% of the time at no downtime and work, right? Like it's near impossible that that's going to happen. So cool. So how do we do this with scale? Okay. So before we jump into the actual design, we need to ask, well, okay, well, like you're telling me to design a URL shortener. Well, what's the length of the actual URL to be shortened, right? Like, like what do you want? Like 7 characters, 3 characters? Always, I think a good rule of thumb is to always ask, I'd say around 3 to 5, probably 5 minutes of questions, just like what you can get out of it. Like, what if they just tell you like, oh yeah, we just, you know, that's a great question, right? Like what, we don't want it to be that short. Like we want to make it like almost identical to the longer. I don't know if everyone wants to do that, but it's always good to ask. Another thing, like what is the volume of traffic on our URL app, right? Are we gonna get like, okay, well, if we're gonna get 50 users a day, right? Maybe we can just use a system with, very easy vertical scaling, and maybe AWS has a Proctor support, so we can support the influxes that go in and out, so you can monitor when the downtime and crashes are. Like that would be a very easy solution. What if they tell you that, okay, well, your task is to implement Twitter's new URL shortener feature that will be deployed to, millions of users, and we'll have an implementation of like 3 million users a day, right? Like those are two different things. Okay, so is this single, like I said, is this system single instance? Does it need to be scaled, or should we scale it, right? Like what do we do? And the term for this, or how we get started. So it's always good after asking questions. It knows that you're on a very good start for your interviewer, right? It's like, okay, nice. Like this person is actively listening and taking into account all of the specifics of this design. Like if I said to design Google Docs, right? Like, okay, well, it's a very broad term, right? Yeah, no problem, man. Yeah, well, we're gonna post the vid later. But yeah, like there's so many different things. Like there's so many different working parts and pieces, and it's like, okay, well, usually if they tell you to design like Google Maps or something, you're not gonna be out here designing the entire infrastructure. It's gonna be one key component. Like for Twitter, it's probably gonna be like the profile page, the tweet page, something like that. So how do we figure out the term to figure out how much data is going in and out is called data capacity modeling. And we need to figure out how much data is going into our system per request, right? So how do we kind of, well, first off, are there any questions about like before, like questions asking interviewers, or kind of the importance of asking questions? What single instances? Does anyone think that should be fine? Okay, cool. So, right, that is basically what how you should start. You're already on a good foot. A lot of them are like, okay, cool. So he's actively asking all the different things. Now let's talk about data capacity modeling. So we need to figure out how much data is going into our system, right? Okay, let's think of it. So we always consider the data capacity as an upper bound, right? What that means is we always consider the worst case of what someone can. So let's say that we have this request. Well, let's think about it. So, 1 second. Right. So let's say that as we can actually just do this. Do this here. Okay. Oh God, that's not good. Should be duplicated now. Okay. So let's say that we have like our server as usual, right? Like we have this URL shortener, extend the width and the height, right? So like I said, like before, right? Like we're gonna get a server, like we did in our example. Just color an arbitrary color. Doesn't really matter. Okay, we can just say our algorithm, and our algorithm is actually going to be the URL shortener, right? Like that's literally going to be what our thing is. Okay, so we have this, right? And we have our server. So now, let's think of the data capacity modeling, right? So let's think about the different attributes that we're having into these requests. So we have a request. Let's say that we have a post request. And what is a post request? Well, post request is basically posting data, like the client being able to post data such that the API will use it and get it to a server. So let's just break this down, right? So like we did in the last one, let's say that we have this guy here. This will be our client. And what we're doing is we're sending data here. And we're posting data. So this guy is going to have a post. Okay, and we're posting data. So what data are we posting to this? Sorry, not this algorithm. It's going to be this this kind of bigger server, right? Like that's what we're trying to get at. Okay, so we're trying to say, okay, well, we're posting this to a bigger sort of thing. I hate how it does that. Let me just put something in here. Okay, so for abstraction, right, we have this server and we have this algorithm. We'll label this A, and then we have this server, let's say S, right? Okay, and black is bad for these background. Okay, so we have these two things. We have our server and our algorithm, and what we're doing is we're like posting, sort of posting our thing to here, right? We're doing a post request. So when we post our URL, what are we going to be doing, right? So let's consider the max long URL, right? So the max long URL is around 2048 characters, and we know that each character is 1 byte, right? So that is approximately 2 kilobytes, right? So we have this kind of sketch. So we know that, like, let's say that we have like hello.com slash, the max long URL can actually be 2048 characters, right? So we let our max short URL, that let's say that, from the previous question, they said, okay, well, I'm going to make the max short URL we can get is 17 characters, right? I think that actually should say 7 characters, but whatever. More or less. So right, so we have this restriction. So that's around 17 bytes, right? Because each character is a byte. We're also going to create a timestamp, which is going to be 7 characters, which will probably have the date, like the month date will be created, like 2024, or 2024 2000. So that's not a month. Like 5-24 2020, something like that. So you'll have like an expiry timer. I a timestamp and you have an expiry timer. So this timer is really good because it's kind of like this sort of timer that ticks off, and it will kind of sort of remove the data when that timer ends, right? Like, if we have this database and we have these URLs, so we have such a database here. Okay, move that, and then we have this we have a database in the end, right? So we have like a database here, and it's kind of like, okay, well, if the expiry time is in the database, it'll actually just remove it like from our DB. Like we can establish that. We have our DB here. Okay, so that's the basic like premise of why it's good to model data capacity model, and we add these up, and we tell them, okay, well, that's the next step, right? So for any example, like if we're doing Twitter, if we're doing Google Docs, anything, it's like, okay, well, what is the input? If you kind of think of it, it's kind of more of like a data structure algorithm style, where it's like, okay, what's the input, what's the output? It's more high level and talkative though. It's like, what is the input? Basically, you're basically trying to know what is the input, and they're going to tell you, okay, well, we know that the user is going to give you a post request, so that's your input. Okay, let's model this. We know that the data capacity of this is around 2.031 kilobytes of data, right? Okay, and it's just some simple math, right? Now we need to calculate our instance to scale. So that's our specific instance for one request, right? Like for instance, we have a max. This is an upper bound of 2.031 kilobytes per request. Now let's assume that our interviewer gives you a scale of 30 million users over a month span, right? Now you can kind of see how that's a lot of data that needs to be stored. That's a lot of scale. So our usage per month would actually be around 60.7 gigabytes, which can actually lead to 0.7 terabytes a year, which is 3.6 terabytes in 5 years, right? Like I was talking to my friend, and he said that I don't know if you guys are familiar with Splunk, but his company every day gave Splunk a post request is such that, it's way more formal, of just dumping data onto their system with 500 terabytes a day, like 500 terabytes of data. And I think the company was Disney, like Disney Animator Studios, and they gave Splunk 500 terabytes a day. So like you can kind of show how crazy scale works, right? Like, so it's really good. It's always so good to talk about this kind of scale to the interview, right? It's such a good, and kind of when designing systems, it's really good for that. So we have this, these numbers to work with, right? It's always good. Sorry, I didn't put in the slides, but it's good to mention a time frame. Like how long of a time frame are we asking for this system, right? Is this going to be a 5-year thing? Is it going to be something held concurrently? Is it only going to be 3 months? Do we only need this for a certain event, right? So it's always good to kind of do that, and then do your calculations from your instance. So once we got our instance, do your calculations based on the time frame they give you, right? It just shows so much formality and professionalism, not professionalism, but like it's just so much very good engineering of being able to lay down your requirements, kind of like test-driven development in a way, laying down all the things that need to be done and sort of all the requirements before we just go about building the system. It's very similar to going on LeetCode and saying, instead of like talking with the interviewer about your problem, just saying, okay, well, I'm gonna write a for loop here, like, and just start writing a for loop. Like, like it's always great to just voice what you think the system requirements are, what you think everything's happening before this actually happens, right? So, okay. Is there any questions about any objections as well? If you guys think there's a better way to approach the start of a system design interview or designing a system, if there's anything you do differently, please, I'd love to know what you would think. My personal route would be to lay out all the requirements. First off, ask all the questions, lay out all the requirements, make a data capacity model of a specific instance, and then make that instance to scale based on the time frame that they give you when you ask that question, right? So, Any questions? That's good. Did you ask upfront what features you want? Yes. So yes, no, definitely that's an sorry, yeah. So a big thing for the questions is asking what features exactly. So if they say, hey, you're on your Twitter final round, right? You're on this whiteboard, there's it's in person, and they say, hey, can you give me a rough design of what you want Twitter to be? They go very vague. They will do that to you on purpose. They will say, okay, well, let's see what you can do. And 99% of the time, they want you to pick, or they want you to ask them, okay, well, Twitter is a very general and broad thing. Is there something very tangible that we can get done in 45 minutes, right? Like, you're only going to get 45 minutes for this. So then they're often going to say, yeah, can you just do the profile page? Or what about the tweet page? Can you do for Google Docs, can you just do the edit page, stuff like that. So good question. Yeah, it's always good to ask up front. So when you're asking all these questions, hey, what functionalities do you want in this URL shortener? Do you just want the basic tiny URL where you're given that? Is that it? And then scalability after that. So yeah, good question. Is there any other questions? Okay. So we're gonna move on. So what's the core logic of our URL shortener that we so the next thing, right, is kind of devising the core logic that we need to kind of create this URL, right? We're given a long URL. So we have this example.com / up to 2048 characters. We need to condense this into a deterministic and unique short URL, right? Like, we can't just say 101. Like, we need some sort of function, some hashing function, some anything really. And we need to kind of condense this in a way such that each URL is individually unique and deterministic from each other, which means that if we get /101, we're not able to go back to that long URL, right? Like hashing in one way, right? Like a really good analogy of like hashing is you take these fruits and then you blend them in a smoothie and you can get a smoothie, right? Like, you can go from fruit to smoothie, but you can't go from the smoothie to the fruit again, right? Like, there's no way you can kind of recreate that fruit, right? It's hashing. We're going from, it's one way implicated. So okay, so now it can be anything. Like I said, like, we do Google Docs, we do Twitter. Okay, what's the functionality of the core pages there, right? Like, we have a push request, having the user information. We need to display it in a way such that it's represented nice. Like Google Docs, we need, for doing the edit page, we need like a socket. We need some sort of IP interaction, some sort of like socket layer to ensure that all the connections are shared. Same thing with really, yeah. So, but this is very simple, right? So this is our logic, and it's going to become very apparent to you that the main brunt of this is seeing exactly what I said, right? We need to condense the URL in a way such that it's hashed deterministically. And it's very sort of trivial and naive to say, okay, well, yeah, we can just use some random hashing function. But it's not that simple, right? Like, what if we gave you around 3 million requests a day, right? Like, if we have a hashing function that just like takes all of these, the sum of all of the numbers, and then modulus that by the length, right? You're going to ensure there is going to be a collision, right? Like, if you brute force all the possible permutations, you'll eventually find a collision. And when that collision happens, you're going to have one guy type in this short URL, and it's going to be redirected to not what he wants. And that is pure data corruption, which will render your site completely obsolete. That guy's probably going to report it, and you're it's just a very bad design, and it's going to take a long time to recover from that, right? The biggest thing in system design is to avoid data corruption, avoid that sort of experience, because that is personal data. Like, imagine someone's doing a short URL to like their like marriage doc. I don't know how you do that. I don't know who'd plug in their marriage documents to like tiny URL, but you never know. Some people. But and then imagine the guy that's just trying to go on YouTube and then he types in a short URL to make it convenient, and then it's just some dude's marriage document, and it's like, okay, I guess. Um, so okay, there's two ways to approach this. Base 62, which is pretty explanatory. It's base 62 and MD5 hash. But first off, we need to get our two API points, right? So how are we going to do that? We're going to have a create short URL, and we're going to have a create long URL. So sorry for my really bad color scheme. It's very, I'm just coloring in different colors. We have our API, and within this API, we're going to have 2 points, right? So we're going to have sort of this API, right? And we're sort of going to have two different kind of requests coming in. So we're going to have two things, right? It's going to be a create short URL, which is going to be a post request. We're posting a URL that we're creating. And additionally, we're going to be getting, right? We're going to get the long URL from this database, right? So does that make sense? So we are sort of, wait, did I do that wrong? Yeah, no. So so the post request, my bad, is giving the server, right, our long URL. We're saying, okay, here's our long URL. And it's going to go to the API and say, okay, cool. So now what this algorithm is doing, it's remember, it's our algorithm, it's our hashing thing that we've done. We're going to say, okay, we're giving this long URL as an input. We're going to do the respective algorithm, and we're going to, go to the database. We're going to check, okay, is this in our database? Is this not in our database? And what we're going to do is, okay, say everything checks out. We're going to just get that respective, we're going to post the short URL in the database, right? And then we're good. And whenever we are getting, wherever we're kind of creating the short URL, right? What it's happening is it's, okay, we're going to go into the database. Whatever database is mapped from that long URL to the short URL, we're going to get it, right? We're going to get the respective short URL, and we're just going to return it back to the user, right? So that's the basic, the very bare bones structure of how it's going to work, right? Does that make sense? Not to scale, by the way. This is not scaling. This is just basically how you would intuitively do it, right? Do all the requests, the different requests and routing make sense to everyone? Cool. Okay, so we have that. More in hashing, right? So this is kind of, okay, so another thing is in these system design interviews, it must be very broad, but there's this certain thing that is kind of a data structures problem on it, not data structures, but it's a meaty problem on its own, right? And they're probably going to say, oh, cool, yeah, very nice basic design here. Can you go more in depth about how you would be more deterministic about the hashing? And that's like one of the meat of the interview. Like that's another meat. Like say you're designing Twitter or Google Docs, and you're saying, okay, well, we have this feature and we need to make sure that it's authenticated, right? They're going to say, oh yeah, that's really good. You mentioned authentication. How would you go about making sure that this authentication is working, right? So you'd say, okay, yeah, I'd go and I'd like salt the hashes. I'd like use some sort of library to compare, right? There's a real meat of what we want to get, right? So more on hashing. So what if there's a collision, right? Like I said, how do we prevent this data corruption? So I shouldn't say solution, but naive solution is we must do a pre-check if the URL hash is already present in our database. If it is, right? So let's say that we have 101, like we go here. Okay, cool, we get 101. So 101 is now mapped to a long URL in our database. Everything's good. Well, let's suppose that we have another hash, and that's 101. Okay, well, this in the database, we have a 101 that already exists, right? And if this already exists, then we just generate a new hash, like 202. Okay, that's good. So then we put it there, right? So very good for a single instance machine, right? Like we can see how that would work. And depending on how big your hash wants to be, it would work, right? But the problem, okay, so let's actually first go more into like what hashing technique we would do. So base 62, the reason why it's 62 is because we have 26 capital A to Z characters, we have 26 lowercase a to z characters, and we have 10 characters from 0 to 9, so that would add up to 62. And now by a sort of a counting argument, right, we have 62 choices with a length of 7, and by like, you know, binomial coefficients, we get that 62 to the power of 7 is around 3.5 trillion combinations, right? Just doing the math. Compared to base 10, where we have 10 choices, right? 0 through 9, with length 7, right? Why is it length 7? Because our interviewer said, hey, when we're doing our URL, why is this not going to tab? But like when we're doing this, right, it can only be like 7 characters long, right? That's why it's base 7, right? So that's kind of a really good plus about using the like a base 62 algorithm. And it's very good in these system design interviewers to say, hey, I'm able to abstract and I'm able to encapsulate all of my high level thinking. However, if you want to go in depth about a specific feature, such as I'd say a hashing thing, then you're able to communicate with them how you do this. And that's kind of where your like data structure algorithm stuff comes into play. Right. So I'm just trying to like hit home that although it is very good to design a system, they are going to give you a very pivotal question that's going in depth about a specific implementation and design choice that you used, right? Like, right. So are there any questions about B62 and like the deterministic hashing algorithm that I used? Let me just do this. I actually wrote a Python code about it. So yeah, so you know, you have this string and you have this hash. And you would just, you know, calculate a new hash string for this, right? So, are there any questions? I mean, I'm kind of beating like a dead horse here. Like, I mean, I just want to. That's kind of how we do it. But for a single instance, this would be really good. What did we say about collision resolution? Right. So collision resolution, right? So let's say that we have client A, and client A says, okay, I have this huge URL, and we have 101, right? We map to, if you look at the screen, we get with 101. So we're gonna check our API. We're gonna say, okay, well, our 101 is not in the database, so let's put it in the database. Okay, so then let's say that we have another client. Let's say client B, and client B gets the same URL, the same 101. So how do we prevent that? We can just do a very simple check. Okay, well, if this 101 doesn't exist in the database, we would kind of put, it's kind of like a set, right? If this 101 is not in the database originally, then we would put it in. If it exists, then we would just generate a new hash. We would rerun the hash function. So this is collision resolution for a single instance machine, right? This is for one instance, right? But I will foreshadow that. Let's say that we have multiple machines running in parallel with each other, and each of them both generate the same hash at the same time, right? Our specific algorithm and implementation has no way of ensuring that the error check is right? Because we're going to have 101s in parallel. It's asynchronous, which means that this is not dependent on this. So both collision checks are going to happen at the same time. And the result is both of these are going to go into the database at the same time. We're going to have two 101s in the database, right? And that's a problem. And we haven't even addressed that yet, right? That's a problem because, you know, and you can think, let's say that we have n amount of clients and let, you know, the probability of collision gets you know, more evident as more clients come, right? So that is a serious concern, and we'll be addressing that. So right now we're just talking about the actual algorithm, and that's how we prevent single collisions, right? But like I said, this is system design, not single system design, and we need to make it scalable for a high influx of users, right? If that's what they give us, which usually they will. So cool. Did I answer your question? Okay, well, if we did, I'm gonna move on. Nice. So now, like, let's think of, um, yeah, yeah. So, first off, let's say that we have our single engine system, and the thing is, we need to make this scalable. We need to make this, a lot of things. But first off, when we're doing these interviews, we need to make sure that it works for a single instance. Like if the algorithm and the design doesn't work for a single instance computer, how are we going to make this work for millions of computers across the world, right? So let's think of different things, different choices, different drawbacks, anything in our system. We have this DB, right? We have this database. We can't really do much with a server for optimizations, maybe run it in a specific language. Even then, it's like whatever. A very big component of system design interviews is what type of database should we use, right? And a lot of people have their subjective opinions, but we have these different options, such as called like things like NoSQL, NoSQL, RDMS, which is Relational Database Management Systems, and these two things are used for different things, right? Like we have RDMS. So what RDMS is basically SQL, PostgreSQL, anything relational where it has structured tables and structured columns. And you can see that it's very good, right? Like it's very neat. The data is very strict. The tabling, which is good. But imagine we have an n amount of kind of entries, and if you look at the tail end behavior, it's going super huge. It's growing, and it's very hard to scale this, right? Because like the columns they might be very strict. The information inputted and outputted are going to throw back a lot of errors. It's going to be, okay, you didn't do this right. This format wasn't correct. Um, and just think about the situation that we're doing, right? It all pertains to what we're doing. We're doing a URL system, right? We don't really need RDMS for this. All we really need is two things. We just literally need a couple of columns. We need short and long URLs and timestamp and expiry date, right? And it's very easy to kind of sift through all of them and not sort of and not have this very strict relation, right? Like it's yeah. So yeah, so that's another thing of NoSQL. So NoSQL, I mean, there's a very like not in depth, but there's another thing about like how it would be useful. But what we can do for NoSQL, it's very how do I say? It's unoriented and non-relational, and like it is very good for scaling because all of the nodes in the NoSQL database will sort of bounce off and look at each other. So it's a little, you can look it up yourself, a little more complicated, but um, all we have to know when we're designing these crazy like applications that are a lot of users, we just need to realize that this is very good for very high scaling applications, right? So think of high scaling NoSQL, and a lot of people will be like, there's a lot of debate about this, but in terms of like designing a system, it's more logical to make a NoSQL database, right? So options would be like MongoDB, stuff like that. So I can just like expand this guy, and then I can just say like, so there'd be a MongoDB database here. So it'd be like MongoDB, right? Something like that. Or any really NoSQL database that you can really find. So, and then they would probably ask, yeah. So, yeah, are there any questions about like differences between RDMS and NoSQL? And like I said, I just want to tell you that like when you're at an interview, they are going to give you these questions like, okay, well, you're going to say, okay, I'm going to set up a database. Okay, well, why would you use this database? What type of database would you use? Same thing with like a server and API. Like what server would you build this off of, right? Like if we're doing a very strict and hard and enterprise application, then it requires a lot of robust support. Maybe Java and Spring is a very good backend. However, if we're doing something very fast-paced, you want to get this up really quickly, maybe, and very, that's very disorganized in a way too. Maybe a Node.js Express MongoDB backend would be better, right? So it's a lot of drawbacks and trade-offs that you need to discuss with your interviewer. And we need a mind to use consistent hashing. We'll go over that later. But yeah, there's no questions. Cool. So we have that. And we have, let me just concrete this. Like I said, right, we have a post request and we also have a get request, right? Like so our post request is like, okay, hey, this is the short URL and the long URL pair. Get request is, hey, I want to get the short URL that I need, right? I want to get this back to my phone, right? I'm going to post the long URL. It's going to do the algorithm, post a long URL with the short URL into the database, the NoSQL database, and what it's going to shoot back out is the short URL that we can give to the user. I just wanted to make it green. But anyway, so yeah. NoSQL, right? So like I said, eventual consistency takes time to replicate change to a different node. Replication copies data across multiple servers, so each bit of data can be found in multiple places. There's good visualizations you can see. Like, so let's say that we have a node in our NoSQL database and we have a bunch of servers. It takes time for the data to replicate. That's the whole structure of a NoSQL. Whereas SQL is very centralized, right? There's a single point. There's some sort of consistency. But the thing is here, it's very scalable, right? Like as you have so many requests, you can easily kind of put this, think of it as kind of like a hash map, right? Like you have this huge map and you're kind of just looking for what you want. You're not sifting through the entire SQL querying table and finding the column that pertains to it. It's kind of like, okay, this is what I want. Like very nice unstructured querying. So really good trade-off. So yeah, so if they ever discuss to you guys what that is, then okay, so we converted it to base 62. Like our algorithm's good, right? Like we're here. It's very good. Like everything's working out. Everything's all fine, right? Like we have it. We have our algorithm, our server, and the solutions may sound pretty trivial, right? It's like we're done. And what someone in like Amory in the chat said before, like, okay, well, the interviewer might say, well, you're not done. What about collision resolution? What about scalability? Like now we can kind of reason to them that this works on a single instance, right? But what about if we have n number, like let's say we have like an insane number of clients, like influx of clients, and they're all on our server in parallel, right? Like they're not gonna go on our website and say, okay, well, can you wait? This guy's using it. Like that's never, I mean, maybe unless you play like League or something, and then the queue times suck, but we didn't talk about that. Anyway, yeah, like you want to have this happen asynchronously, and we want to make the functionality so it happens. So, we store the long URL and hash short URL in the database, index short URL, and return, and then we're done, right? Like that's it. Well, maybe, yeah, you can check if our guaranteed hash exists in the database. If it does, then we just generate a new one. This works on a single instance, but what if there's parallel processes, right? Like what if all of these work asynchronously? Multiple clients. Let's say that we have n clients that are making m requests to your server, which are in like, if we look at this, asymptotically, like very high upper bound, like let's assume that our influx of requests exceed 30 million. Now let's suppose two hashes map to the same URL. So let's say that we have this 30 million, like there's a crazy day, there's 30 million requests, right? On this entry point to our server, right? Like there's 30 million clients here. That is not what I wanted to do. Anyway, what the frick? Okay, anyway, you get the point. There's like a lot of clients here, such that there's so many, and there's so many requests. Okay, and now let's suppose that two hashes map up to the same short URL, right? So like we said earlier, so same 7-digit number, right? So let's say that like we get 101, maybe not 101 because we want it to hash to a 7-digit number because of base 62. So we get like 190492993H, right? Because it can be really anything. So we get this, and we get too long URLs to hash to this in this system, right? Like that's a problem because we have so many clients. We have 30 million requests, and we only have, limited amount of time to do such a not amount of time, but like I said, like the analogy that I said earlier, where it's like, okay, well, let's say that this guy's trying to make a short URL to display YouTube video, and the other guy is having really sensitive work authorization documents that has his like SSN social security card. Like, we want to make sure that if the guy that clicks on the YouTube video, he doesn't get rerouted to that card, right? Like, we want to make sure that that is not injective. So okay, so collision problems with multiple clients. Now, these two clients successfully input the same hash into the database, right? Let's suppose that, okay, well, like we said earlier, like we explained, like these, input them at the same time because they're happening in parallel. Remember, these run in parallel. Problem: the next time the user queries the short URL, will redirect to a different link, right? It's randomized. It's due to the NoSQL nature of MongoDB. It just redirects. So before we move on, is there any suggestions on how to resolve such a collision such that we have these instances and they're running in parallel and they're colliding? Is there any suggestions on how we would how you would go about this, right? Like if the interviewer gives you this, what would you do? And it's pretty involved, right? Like it's not easy by any means. So cool. Well, how would we fix this? Well, let's say that we have like this counter. Like, well, how about we have a counter, right? Low. So let's say, okay, well, every time that we make a transaction, so every time that we have a request, we're gonna have a counter, like 1, right? So like I go here, and then I have this counter variable, and it's gonna be set, right? Yeah. Right, I'm gonna have like a counter, right? So which is really good, right? Because we can attach this counter to our attributes, right? Like let's say this guy comes in, okay, counter is 1. We just need to check, okay, well, is this counter the same number? So let's say the counter is going to be 1 here, right? This guy, say they're all operating in parallel. This white guy and the blue one are going at the same time. So this white one is going to say, okay, the counter is 1. And this guy is going to say, okay, well, the counter is 1. Well, we don't want the counter to be 1, right? We don't want it to be the same. So we map them with counter 1, and then this guy eventually is going to be counter 2. And already you can kind of see how this is a little weird, right? Like, first off, like, who's to say, like, this is a local, like you'll see here, it's really hard to add these local counters on hosts, right? It's like, okay, well, how do I know that this guy, first off, sorry about that. Let me, first off, I would definitely say, like, we're already moving past the single instance, right? So we need to have some hybrid scaling, like vertical and horizontal scaling, in order to sort of, facilitate more servers, right? So we'll have this guy. I can just copy and then paste. So I have these separate servers, right? And what I was proposing is that like we have such counters, such that like we have counters such that like on each one of these servers, right? So we have these replicated servers that are supporting all of these, and we have counters, right? Like that can be bad because it's like, okay, well, what server has priority? What server is best to do this counter? Like if you have a counter here, how do we know it doesn't conflict with this counter here? So it's hard to configure and route all the local counters up, right? Like it's almost impossible, really. You can have like system admins do it, right? Like you can have people say, okay, well, you know, these are going to be like the, you're going to have people around the clock looking, okay, well, is this kind of good? But that costs a lot of money and time, and probably, there's a way better way to do this. So how do we sort of fix this problem? Encounters. What we can do is we can apply a zookeeper service. So what are zookeepers? These are very important in system design. So let's suppose that we are scaling horizontally with many host machines at our disposal. And we can think of these like host machines as animals. Like they're animals in this zoo. Like we have this is like whatever, like a tiger, dog, whatever. And they're all riled up. And what if we had the central zookeeper master that herded all these animals together, right? Like you know, we have all of these animals here, and it's like, it's very hard to talk to each other. Like who has priority? They're all just like animals. But like, what if we employed, let's not do that, such a zookeeper, right? Where what happens is we can talk to all of them at once, right? Like we have a way of communicating. So it's kind of like a host platform that communicates to all of the zookeepers, right? And what we can say is, okay, so we have this central zookeeper. So what's happening? What's happening here? So what a zookeeper does is configure all the hosts and coordinates them, right? So what do I mean by that? Okay, well, all of these guys, let's say, first off, let's suppose that these are getting load balanced, right? Like this is a, let's say that this is like a load balancer. So basically it's equally distributing all of these weights to the respective hosts, right? So, okay, well, I'm gonna load balance this guy. This guy's gonna go here. I'm gonna load balance this guy. This guy's gonna go here. I'm gonna load balance this guy. Maybe he's gonna go here as well, right? So these are all getting, these are all hitting an API as well, like just for concreteness. But anyway, they're all hitting an API, and we have all of these clients, right? Like this guy needs more load here. This guy needs more load here, right? So we have all of these clients, and they're getting load balanced. They're going through this load balancer, and how are they going to talk to each other? So what we can do is we can reroute all of these specific client requests into our like zookeeper. So we have this. We're saying, okay, we're gonna go here, here, and we're gonna reroute all of these to this. So what is this? What is it doing? So it assigns unique IDs to each of the hosts. So we can say, okay, this is host 1, this is host 2, this is host 3, stuff like that, right? So it assigns each ID to those, and it has configurations for each host, has a coordinate database which each host can use. So what that means is that each host here has kind of reference to this database, right? Like it can be part of what we're doing, right? So and it maintains synchronization, which means that like, hey, this is the guy that gets to speak, right? Whenever this database is looking for something, right? Like whenever we have some sort of language, we know that we're able to communicate here, right? So we're able to look at the zookeeper and not the individual clients when we're asking for sort of a request, right? So it's really good. It's very, very helpful. So problem solved, right? It's a central service we can get information from. And it's very important to know when sort of riling up all of these hosts. It's really good to have some sort of central admin way to coordinate everything, right? Are there any questions around what Zookeeper is? There's Apache Zookeeper that you can actually download. I was experimenting with it. Is there any questions about like what the use of it is, why it's called that? Is this a service on a load balancer or on its own instance? That's a good question. I think it could actually be used for both. I think conventionally that the load balancer would be available to sort of act on its own, whereas a zookeeper is its own physical or cloud instance on its own. So it's separate, right? So the answer to that would be conventionally it should be separated. We'd have this other piece of technology that we'd route in, given that all of these are load balanced already, and that we would route into the zookeeper. So yeah, I think there are some hybrid configurations where you can like load balance and like have such like a intertwine like zookeeper at the same time. But yeah, good question. So is there any other questions? Okay. So, oh, nice. So this is a really cool thing, and it's called caching. So let's say, okay, well, this is fixed, right? We have this harmonious system, and whenever we have this influx of requests, we can keep on scaling, whether it be horizontally, vertically. We can just keep, increasing the number of host machines, right? So we're good. Well, you can kind of see how if we have the central database and it's NoSQL, yes, but you know, here, going to the request here, rerouting to the zookeeper here, and going back to the database, right? The database has to take time to query and look it up. Coming back here and then going to the client is a little bit inefficient, right? Like it's gonna take a bit of time. So how do we solve this? How do we solve like this is a very important, concept. Like how do we kind of solve this? Is there a way where we can literally just, you know, take all of these steps and kind of out really when we do our first initial thing, right? And the answer is caching. So our no collision model over Zookeeper is great. However, this might be a little slow and has to compare so many IDs and stuff in the database. So we use caching. So what is a cache? What we always hear that. What's a data cache? A cache is just a storage, a temporary storage. That's all you need to know. It's a place to store temporary information. So this information is going to be there temporarily and it's going to expire. That's all you need to know. Like, I don't know why it's such a taboo subject and it's so hard. Like, that's literally a very, I mean, obviously there's different kinds of caches. But yeah, so what is a cache and why would it be useful? Well, if we can have this sort of data structure, this sort of service that lets us store temporary information, well, it would be very good, right? Because request after going to server gets cached. So let's say that we request something. Okay, well, I'm gonna go to the server and I'm gonna request, this request is gonna come here, this post request, right? And let's just take this guy here and color this like yellow. And let's suppose that this guy gets cached, right? So, we have a sort of data cache. We have this sort of cache, right? And okay, well, it's getting cached in. So, what are we caching in? Well, we're caching maybe a hash ID of the post and get request. So like, let's say we have a long URL and a short URL, right? And it's also going to have like an ID and stuff. We're going to cache the ID. We're going to put it into our cache. And in this cache, let's say that we have this ID, again, equals 3, right? Which is kind of like a thing that will, okay, well, we have this ID. So this request is an ID of 3. Now we're going to put it in our cache, right? So now we can easily provide a mapping instead of looking to the database server. So when this, happens the first way around, this goes into the load balancer, this hits the API, this goes to the server, the algorithm happens after the zookeeper, it goes to the database and then shoots back out, right? Well, we don't need to do that again. All we need to do is we have this check. Well, we're going to check the data cache. If it's in the cache, we're literally just going to return the previous response, right? Let's say we have a response. This is going to be a response here. And the response has like long URL. The response is going to have like short URL 407, right? We're going to cache the ID that has the response 407. So when we call a specific request again, the same request, we're going to check the cache and we're going to say, oh, well, ID 3 is here. So that means we literally made this calculation already. So might as well just we can just easily shoot back out the response that we saved, right? Remember, this cache is also going to cache the responses as well, right? Does that make sense? So, right, and the thing is, it's going to expire, right? So all these caches has an expiry. That's kind of why we put the expiry time, if we remembered, on our data capacity model. We put that. So now we can easily provide a mapping instead of looking into the database server. Has an expiry time, so good for a temporary pass lookup. But yeah, oops. So yeah, does that make sense? Really good for large amounts of people needed to view the URL in a short amount of time. Like there's a huge influx of people, and we need to view the URL. No worries, man. See you, dude. Yeah, and we're almost done too, guys. So finish it up. But anyway, yeah. Really good for large amounts of people. Need to view URLs in a short amount of time. So if it's not already in the cache, right, then we just check our database. And we're done. Surprisingly, this is one of the optimal things. And you can see here, we have our, it's much nicer, but we have our URL shortener. That's okay. So if we have our sort of model that we did for scalability, we can, if they ask to scale more, we would scale more servers horizontally and vertically. We would have a load balancer balancing all the clients and requests. They send the requests and information to our API and our server. Before anything can happen, we need to check, okay, is the Zookeeper allowing us to make that request? Is the Zookeeper allowing, like, the thing about the Zookeeper, let me go back, is that this Zookeeper is going to store the counter, right? And we don't even need to check if the short or long arrow is in the database anymore. We can just check, okay, well, is the counter a unique number? Like, let's suppose that we have a counter here, and this guy has a count, like this request has a counter of 5, right? Goes to Zookeeper counter of 5. And we just need to check if the counter is unique, right? So if this is 5 and this is 5, these are both 5, then it's not going to work, right? Like the Zookeeper is going to reject that because we want the counter to be unique. And so it'll make it 6. So if we have unique counters, we can ensure that all the information is uniquely stored in our database to prevent collisions in the off chance that a collision does happen, right? Because we are given so many permutations of different things, right? So yeah, so we're basically done. That is our URL. We can also add extra functionality. We can do things like setting up Google Analytics, right, to set up the performance of our application. We can go more in depth. Let's say that we want to have this certification, this SSL certificate, right? Maybe we can, maybe they want to go about making it certified. How are we going to go getting this certified? The DNS token, stuff like that. How maybe we need a custom DNS mapping, that has our certain URL mapping name. So like tinyurl.com, we would need, maybe they'll ask you, like, these are all questions that they might ask you, some extra features. Another thing is they'll ask you to deploy it on sort of a platform, DigitalOcean, Heroku, etc. Like Firebase, or not Firebase, but like Netlify if you're doing front end stuff. And that's really it. And that was our demo, and I think we're good on that. But yeah, and then are there any? We were gonna do this, but I think that should be okay. We really went along like this. I hope you guys learned a lot. Is there any questions about anything? Any comments too that you guys might have? About the whole system design process. Like that. But yeah, I think we just ended cool. So I mean, it's around 7. Thank you so much, guys, for taking the time out of your day to kind of learn about this with me. Yeah. Oh, thanks so much, man. Yeah. No worries. I'll explain the counter. I'll explain the counter again. Yeah, no worries. Thank you. So yeah, so the counter, right? So what we can say is, let's say that we have our Zookeeper, and we have this counter. So let's suppose that we have this guy, and let's call him client one. So client one, if we use the zookeeper methodology, we're going to the zookeeper, and client one is going to have a counter of one, right? That's the counter is basically how many. We can just say what is the count of all the URLs that we have right now. So we have one URL. So one, okay, we have one. We're going to store a one in the database, right? Okay, and it's going to go. This guy has a count of two. So all these counts are going to be unique, right? Let's say that let's say that this guy and this guy can right, sorry about that. It is right, so it is maintained in the zookeeper. Yes, it's not maintained on its own, and the zookeeper is kind of the guy that's saying, okay, I'm going to be directing all of the counters for us. So I have all these guys here, and it's going to go here. Counter's going to be one, counter's going to be two, counter's going to be three. Two of these hit at the same exact time, right? Like this request is going to be here, this request is going to be here, right? Like this request goes into this server, that request goes into this server, but we have a zookeeper. So the zookeeper is going to say, okay, well, let's say server with this ID, we're going to assign this guy with a counter of 6, and we're going to assign this guy with a counter of 7, guaranteeing that the counters will be unique. Thus guaranteeing that every time that we make a request to the database, our counters that get passed in will be all of unique reference, right? It was very hard to establish a counter on local instances, right? Like, we can't do this because who's to say that this guy's going here? How does this guy communicate with this guy? How does this guy communicate with this guy? It's impossible, right? It is, but let's have a central hub where we can store this counter. And once we have this hub, we can sort of reroute and direct the traffic to the database. So now the counters for each one of these clients will all be unique, right? Because the zookeeper is assigning it. It's like a teacher assigning unique numbers to a class. Like, okay, you're 70, next, you're 71, next, you're 72. Therefore ensuring that we have a unique system. And obviously we have error checking, the zookeeper is gonna say, right, what am I trying to have around is the counter for each request is used. Oh, okay. Each request used is the counter for each request used in the DB table as like a unique ID. Pretty much, yeah. Because yes, the thing is, right? Like we have this idea of 71, 72. We're guaranteeing that two counters will like. Do you believe that every counter that going into the database will be unique, right? It will, right? Because we have this. This zookeeper is saying, let's say that all of these three hosts are triggered at the same time, right? So these are all going to the zookeeper. So we have host 1, host 2, and host 3. And the zookeeper is saying, okay, we're gonna look at all of these three hosts, and we're gonna look at all the short URLs for these three hosts, right? And as long as the short URL for these three hosts are unique to each other, right? As long as they're unique, we're going to assign a running counter, really, a different counter to this specific request, right? So if it's 101, 101, and 101, we know that the zookeeper is going to reject this information, and it's going to say, okay, well, you guys need to go back. You like animals, you whatever, you need to go back and you need to rehash the algorithm. We're going to come back. It's going to be 101, 101, 102. Okay, 102 can go. 102 is fine. 101, 101, you guys need to go back and refunnel information. Does that make sense? Okay, right. And it's very, like I said, it's not as simple as just like a counter, right? There's a lot of formalities and specifications of how it is. It's just that a zookeeper is a very good central rerouting hub where, and like once the counter is sort of stored in the data. Yeah, I think, like I said, I think I know what you're saying here. The counter instance can be a little voided, right? Because, I mean, due to this terminology, we can kind of assure that we don't really need the counter, like the actual variable. But then again, it's also a good check. There's a lot of database methods that you can say that we can actually scan real quick and see, okay, is this the only unique counter data in our database, right? Like, is this the only 70 in our database? If it's not, then okay, well, maybe there's something else wrong, right? It's a good insurance technique, right? Like if we have like, the off chance that something happens or some downtime, we have this like 270s, the zookeeper like gets shut down, let's say the zookeeper goes out, then okay, well, we have our counters list available here. And before we return a response, before we get it and return a response, we just need to say, okay, well, is our counter, is this guaranteed a unique counter? If it's not, we're going to reject the whole request entirely, right? Because we do not want two unique counters. And what we can do is not only reject the request, we can delete that data entry and delete all other instances of that same counter as well. Does that make sense? Got it. Cool. Yeah. So there's a lot of things, like I said, for system design where it's like there's a lot of trade-offs, there's a lot of extraneous things you can do, but there's also a lot of drawbacks to that, right? There's a lot of things, but hopefully, like I'll give a little last rundown of what we did at a very high level. When you're going into a system design interview, make sure to ask the interviewer, hey, what are all the specifications? Do you want this to be scalable? What are the questions that, how far do you want me to go in depth into this? What features do you want me to design? What is my time frame? How many users? What are the influx of users? Once we got that under our belt, we're going to data capacity model every single request. So, okay, well, every request is going to use this much memory and this much storage. Now we're going to construct a system that is such that scalable, such that it supports and facilitates that amount of storage. Once we have that kind of storage on the way, we can finally get the meat logic of our stuff. Remember how I went pretty in depth about hashing? It can be different things for different things, and maybe brush up on your data structures algorithm knowledge for that. And once we get the meat of the logic, make sure that it supports scalability. If there's different hosts that need to talk to each other, make sure to use some sort of zookeeper or admin method that is able to have these routings. Lastly, if you want for faster lookup, then make sure to do a cache. A cache is very essential, so you don't have to wait for all this requests. We can have a data cache where we can instantly kind of spit out the response as well. Types of databases, we can do that. Scalability and extraneous features. If they ever want to add SSL, custom domains, deployment, you can like research more on that. But yeah, I think that's it. Hopefully you guys learned a thing or two from it, but hopefully you guys are confident enough to thanks a lot, man. Yeah, I appreciate it. But hopefully you guys can really take this knowledge. Interviews are coming up in fall, and especially new grad positions. Hopefully you can take this and really be composed and kind of own it when you guys have that system design part of your interview. But yeah, guys, thank you so much. And I'm gonna stop recording now. Sharing. We'll just go here. Pause.